Hey guys, welcome to this session. And in today's session, we'll be focusing on some libraries important for data science, which are Numpy and Pandas. So we'll actually be going through these two libraries, which will help us to focus mostly on the data science side of things. And also, before we go ahead, if you could just give me a confirmation if everything is fine and if you guys can hear me, that'll be great. So also in the meanwhile, I'd like to tell you guys that we have a free learning platform called as Great Learning Academy, where we have almost 100 courses with respect to data science, artificial intelligence, digital marketing, and a lot more. And once you complete these courses, you will get a certificate which you can go ahead and add onto your resume or onto your LinkedIn page. Also, if you could let me know how many of you folks have attended my previous sessions and for how many of you this is your first session in this live series. So also, I'm not really well today, so you would notice that there's my voice would sound odd, so I've got a blocked nose, and I also might be coughing a lot, so I'd like to apologize in advance for that. Great. So I see that some of you folks are new for this session. So anyhow, um, uh, so if you haven't attended the previous sessions, what you can do is maybe someone from the moderators team could put up the link over here, and you can go ahead and watch those two sessions, and you'll be able to figure out what is happening in today's particular session. Um, so now that we have this set, so also as what I try to do is mostly in my live sessions, I try to keep it as interactive as possible, and we'll also do the same thing today as well. And if you have any doubts, you can put up in the chat, and I will take them up. Great. So I'll quickly go ahead and start off with this library called as Numpy. And this is a Python library which stands for numerical Python, and there's the core library for numeric and scientific computing as it is stated over here. Now what this library does is it provides you with something called as multi-dimensional arrays, and you can go ahead and implement different sort of operations on these multi-dimensional arrays. So we can, as you see, so single dimensional arrays where you just have an array in one single dimension, or maybe you just have, an array in just one single row or one single column. And if you just elongate that to multiple things, you'll get a multi-dimensional array. So our first task would be to import the numpy library, and to do that, we'll type in import numpy as np, and once we import the library, what we'll do is we'll have to create an array. So to create the array, we will type in n1 is equal to np.array, and inside this we will give in a list of values. So as you guys see over here, we are giving it the values 10 to 40, and we are storing that in this variable called as n1, and we print that out over here, and this is the result which we get. And similarly, to create the multi-dimensional array, again we'll import the NumPy library. Then we will create this multi-dimensional array by passing in a list of lists. So here, as you see, I have given one list, and inside that list, I have passed two more lists. So the first list I have values from 10 to 40, and in the second list I have the values from 40 to 10, and I go ahead and store it in this object called as n2, and I print it out, and this is what we get over here. So let's just go ahead to Jupyter Notebook and let's work with that. So here what I'll do is I'll start off by writing import numpy as np. Once we import this, I'll have to create the library. So here I'll write down np dot array, and inside this I'll have to pass in a list of values. So I'll just write down, let's say 1, 2, 3, and 4, and I have stored these values in this object called as n1. Then when I print this out over here, so this is what we'll be getting. Now if I check the type of this, so we have this method called as type, and inside this we'll be passing in the object which we have just created. And as you see, we have successfully created this NumPy array. So the data type over here is numpy.ndarray. Now, so we have created the single dimensional array over here. Now, similarly, we will create the multi-dimensional array as well. So for multi-dimensional array, all we have to do is, instead of here, so as we have just passed in one single list, instead of passing in one single list, we will pass in a list of lists. So here, what I'll do is, I'll just cut this entire thing. I will paste it over here. I'll have another list. Maybe inside this, I'll have 4, 3, 2, and 1. I'll rename this to n2. And now if I print out n2 over here, so here you would see that I have created a two-dimensional NumPy array. So here I've got 2 rows. Similarly, if I check the type of it again, so inside the type method, I will pass in n2. So again, you would see that this is of NumPy n-dimensional array. So now that we have created the single dimensional array and the multi-dimensional array, let's see how can we actually initialize NumPy arrays. So before we head to that, let me actually take up some questions from chat. So if you have any questions, you can put them up over here. I'll parallelly take them up. Shalini Shipra is asking, how can we install libraries in Google Colab? You just have to write in pip install. That's pretty much it. So you'd have to give it an exclamation mark first. Then you will write down pip install. Then you will give in the name of the library that you would want to install. Rohit Sethi is asking any significance of using NumPy. So NumPy is mostly used when it comes to working with images. So let's say if you have any image, if it's a grayscale image or maybe if it's an RGB image. Now, when you talk about the dimension of an image, so let's say if you have a .jpg file of dimension 256 into 256, what does it mean? It's the size of the image, isn't it? So if you have to store this image in Python, how will you do it? So this is where a NumPy array comes in. So you will, what you'll do is you will create a NumPy array of dimension 256 into 256. And in that NumPy array, you'll store this image. But the question is, how are you storing an image in a matrix form or an array form? Because your image, so let's say if it's a grayscale image, then in each cell, the values will be between 0 and 256. So let's say if you take a NumPy array, then at cell 0, 0, you will have a certain value between 0 and 255. Similarly, at cell 0, 1, you will have another value between 0 and 255. So this is how you are storing an image in a NumPy array. Then you can use the different libraries which are present in, you can use the different um, functions or methods which are there in NumPy and use them to manipulate your NumPy array. So I hope that answers your question as well. Gayatri B is asking, why do we use as NP? So this is known as alias. So instead of writing NumPy completely, if you can just consider this to be a shorthand. Instead of writing NumPy completely, we are using it as NP. So here, let's say, now if I want to invoke this completely, I would have to write numpy dot zeros. But instead of writing numpy dot zeros, I have given this an alias or a shorthand of NP, and that is how I am invoking this method. So you can give it any alias, you can call it anything. So this is, so by default we give it the name of NP, but it's totally dependent on you. You can give it any alias that you want. Khushbu is asking what software are you using? I'm using Jupyter Notebook. Rakhi is saying that your voice has changed. Yes, so I'm not really feeling well today. I've got a blocked nose. So that is the problem. I apologize for that. Great. So keep putting up your questions in chat. I will take them up. So now that we have learned what is a NumPy array, we will see how to initialize a NumPy array. So now if we want a NumPy array, well, let's say all of the values are equal to zeros. So we will use this method called as np.zeros, and inside this we will just give in the dimensions. So here, as you see, I am giving in the values 1, 2, and so as you see, this would give us a NumPy array of dimension 1 cross 2, which is basically a single row and 2 columns over here, and all the values which are present in this NumPy array are equal to 0. Then we have similarly we are creating a 5 cross 5 NumPy array, or the only difference between this and this over here is, so here the dimension is 1, 2, and over here the dimension is 5, 5, and with the help of this we are creating a 5 cross 5 NumPy array where all of the values are equal to zeros. So let's create this NumPy array where all of my values would be equal to zeros. So let's say if I would want 3 cross 3 NumPy array, where all the values are equal to zeros, and I will just store this in a method called as m3. And if I print this out over here, you would see that this is a 3 cross 3 numpy array where all the values are equal to zeros. Similarly, let's say if I want a 10 cross 10 numpy array, so I'll just pass in 10 comma 10 over here, and you would see that we will have 10 rows over here and 10 columns over here, and all the values are equal to zeros. Now, similar to np.zeros, we have another method called as np.full, with the help of which we can create a numpy array with a particular value. So here we have two parameters. The first parameter is just the dimension. So here I am setting the dimension to be 2, 2. Then I will just give it the value with which I would want to fill in my numpy array. And as you see, I've given 10 over here. And we have created this 2 cross 2 numpy array where all the values are equal to 10. Sorry for that, guys. So we were creating a numpy array with the help of this full method. So we had two parameters over here. I will go ahead and I'll give the dimensions over here. So let's say if I would want to create a 5 cross 5 numpy array where I would want, let's say, the number 8 in it. I'll just give it 8 over here. And you have seen that I have created a 5 cross 5 numpy array where all of the values are equal to 8. So then after the np.full method, so we've got the np.arange method, and with the help of now whenever we would want to create a numpy array within a particular range, then we will use this np.arange method. So here, as you see, we are creating this numpy array within this range 10 and 20. Now here 10 is inclusive but 20 is exclusive, which would mean that I will get all the numbers starting from 10 but only going on till 19. So here, as you see, even though we have given 20 over here, the numbers are only going on till 19. Now similarly here we are printing out a range of numbers between 10 and 50, but we have given a new attribute called as skip value. So normally by default the increment between each number over here is 1, but if we but let's say if we don't want the increment to be equal to 1, and if we want to keep it something else, then we have this additional skip value over here. And as you see, I have given this value to be equal to 5, and so here 10 plus 5 becomes 15, 15 plus 5 becomes 20, 20 plus 5 becomes 25, and so on. And that is how we are proceeding over here. And again, since as you see over here, 50 is exclusive, so 45 plus 5 becomes 50. And so let's say instead of 50, if we had given 51 over here, then we would have got the value 50 here as well. So let me just demonstrate this in Jupyter Notebook. I will write down that p dot a range over here. I would just need to, let's say, if I want all of the numbers between 100 and 200, this is what I'll do. I'll just write down np dot a range. I'll give it the initial value. I'll give it the final value. So here, as you see, since this is exclusive, we'll only have numbers till 199. Now, if I would also want 200 to be included, I will change this to be equal to 201. And here, as you see, we have also included 200 now. And if I would want to give a skip value, let's say if I set the skip value to be equal to 10. So this time, so as you see, 100 plus 10 is 110. 110 plus 10 is 120. And this is how we are incrementing or increasing the values in this particular range over here. Then if we would want to, let's say, initialize so as I was saying, if we would want to initialize a numpy array with random integers, then we have this method called as random.random. So random is a submodule from the NumPy library, and we can either have random integers or just random decimal values, or maybe a random random normal distribution or a random binomial distribution. So if you would want random integers from this random library, we'll write down np.random.randint, and I would want random numbers between the range of 1 and 100. So and between the range of 1 to 100, I would need 5 values. So as you see over here, I have got 5 random integer values between 1 and 100. And this is the result which we get over here. So here I'll just write down np.random.random, and inside this I would have to pass in 3 things. So let's say the range is maybe I would want random integers between 500 and 1000, and I would need 10 random integers from over here. So as you have seen, so I've got 10 random integers between the range of 500 and 1000. Similarly, now the interesting thing about this is every time I run this, I will get a different sample of a result. So let's say if I run this now, you would see that I've got different 10 random integers than the earlier one. Now again, if I run this, you would see that I've got 10 different random integers again. So this is how this random int function works. So let me just go back to the session and take up some more questions. Danny N is saying that we can also use np.ones and np.twos. That is also true. So if we use np.ones, then In that case, we get a numpy array with all of the values are ones. Similarly, if we use np.twos, we get a numpy array where all of the values are equal to twos. So there is a question from Perkalai Selvi, and the question is, can we create a three-dimensional array? That's actually interesting. So here, let's say if I do something like this. So three-dimensional array would basically mean that you have these things over here. Let's actually try that out over here. We can actually directly set the shape. So here we've got 4, 8. I'll add just 4 more numbers. So I'll have, let's say, I'll maybe add some random characters over here. I'll have A, B, C, and I'll also have D. And so now that everything is inside this, I have created this. So now if I use np.shape, so currently we have, if I run this, I would have 2 rows and 3 columns, or actually 2 rows and 4 columns. Now, let's say if I have another list, if I copy this entire thing over here, I do Control X, sorry, I actually do Control C and I paste it over here. Now, again, I will put these two again inside one single thing. Seems like we have just this. Let me actually print out and do for you guys over here. So this is something interesting. So here we've got two lists. I'll just check and do dot shape. Okay, so maybe we'll just figure this out later then. So normally the answer is yes, we can create three-dimensional arrays where it's just that you have multiple matrices stacked on top of each other. So we'll just do it in some other session. Prerna is asking why do we use full. So the full method is used to let's say have one particular value in the entire thing. Now generally we would need some dummy values. So let's say if I want the dummy value. So let's say if there's a default value for age and the default value is 25, and what I do is I just create a numpy array of maybe a dimension of 10 cross 10, and in that numpy array I'll just pass in this value of 25. So that is where we can use the full method. So Shalini has an interesting question over here. She's asking, what is the difference between arrays and list? So now when you talk about arrays, I am assuming this is a numpy array. And list in general is the normal data structure. So what you have to understand is a NumPy is a separate data structure from the NumPy library, and on top of this NumPy array, you have a lot more additional functions available. So as you see over here, now if I just create a simple list, if I just have maybe values such as 1, 2, 3, and 4, there are very few things that I can do on top of this list. But instead, if I convert this into a NumPy array, then as you see over here, there are multiple functions which are present, and I can implement all of those different types of functions on top of that NumPy array. So that is one thing. And also, um, NumPy array is it's much more faster during computation when compared to a list. So that is why also NumPy array is more preferred than a list. So you can consider these two to be the major differences between a simple list and a NumPy array. Anita is asking a random sub package from NumPy. Yeah, you can call it a sub module to be a sub module from the NumPy library. Right. So I have taken up some of your questions, and I'll head back to the session right now. So guys, I apologize that I am not at my best today, and I'm not able to teach properly. So even though if you have if you find this session insightful till now, if you guys could just hit the like button, that will be very helpful for us because that is something which would encourage us to come up with more such live sessions. So if you could just hit the like button, and also if you haven't yet subscribed to our channel, if you could also subscribe to our channel, that will be wonderful. So now that we have done this, so as I was showing you guys, once we have created a NumPy array, if we would want to check the shape of a NumPy array, so as you see over here, I have created this NumPy array and I have stored this in this object called as n1, and after that I'm checking the shape of it. So when I use n1 dot shape, so this would tell me that there are two columns or two rows and three columns. And if I would want to change the shape of it, so here as you see, I'm using the same method n1 dot shape, but now I am assigning the values. So here as you see, I am assigning the values 3, 2, and initially the shape was 2, 3, but after this you would see that the shape has changed to 3, 2. Then we have some interesting join operations with yeah. Then we have some interesting join operations with respect to NumPy. So we've got the vertical stack, the horizontal stack, and the column stack. So we have two NumPy arrays over here, n1 and n2. In N1, N1 is just a NumPy array where I have the values 10, 20, and 30. N2 is a NumPy array where I have the values 40, 50, and 60. Then, if I would want to vertically stack them, then I will use the vstack method here as you see. I have np dot vstack. Inside this, I am passing in n1 and n2. And once I pass in these two objects, you would see that the n1 array is tagged on top and n2 array is tagged on bottom. So this is how we can use vstack to stack two numpy arrays on top of each other. Then we have the headstack method, with the help of which we can stack two numpy arrays at the back end of each other. So here, as you see, when I use np.headstack and I pass in n1.n2 or n1, n2. So first I have 10, 20, and 30, and then at the back end of it. So after 10, 20, 30, so this has been horizontally attached to the first numpy array. Then we've got the column stack. So when we are using the column stack method, then these will be stacked with respect to columns. So here, as you see, the first numpy array has been put into the first column. The second numpy array has been put into the second column. So this is how we can work with these three different stacking methods. I'll just create two numpy arrays over here, and one is equal to np dot. So let's see. Inside this, my first numpy array, I'll just have the values 1, 2, and 3, and 2. Here I will have the values 4, 5, and 6. So now that I have created these two numpy arrays, I'd have to use the vertical stack. So let's say if I write down np dot vstack over here, and inside this, if I pass in n1 and n2, so here I'd have to give in another pair of braces, and then that another pair of braces, when I give in n1 and n2, you would see that I have stacked these two numpy arrays on top of each other. So this is vertical stacking of numpy arrays. Then we will horizontally stack these two numpy arrays. So to horizontally stack these two numpy arrays, the command would be the same. It's just that instead of using vstack, we'll be using headstack, and the parameters are again n1 and n2. So here 1, 2, 3 is what you have. Then we have attached 4, 5, 6 horizontally to it. Then we have column stack. So np dot column stack, and inside this I'll just write down n1 and 2. So here we have done this. So that's a question from Percolai Selvi. Is column stack similar to transpose in metrics? No. And transpose, what you're doing is interchanging the rows and columns. So if you have the first row would become the first column. Similarly, if you have the second row would become the second column. But that is not what we are doing over here. In column stack, all we are doing is we are putting them in columns. That's it. So we had an array called as n1. So here we have created this array called as n1, and we are putting this array into column 1. Similarly, we have another array called as n2, and we are putting them into column 2. So that's pretty much what we are doing with respect to column stack. We were also supposed to cover the concept of pandas today. We've got only 20 minutes left. We will cover these and some of the live sessions. So, I am anyway regularly taking a lot of live sessions. So, I've given you a brief of the NumPy library, and I'm pretty sure I would have missed out on a lot of topics. So, we'll cover that in some other session. And also, if I'm not able to take any of your questions today, I would like to apologize for that. and We also have a Q&A session coming up. This is the fourth session actually of this Pandas live series, and most probably on and Sorry again, guys. So as I was saying, most probably this Sunday we have will do a Q&A session where you can ask me questions related to whatever we have covered in the first four sessions. So we have covered all of the basics of Python. We have covered flow control statements. We have covered object-oriented programming, and today we have started off with Python libraries. We'll be if you have any doubts, so attendees who have gone through all of the live sessions, if you have any doubts, you can ask them in the next live session on Sunday. Right. So today's agenda was actually Numpy and Pandas, both of them. Since both of them are quite extensive, we can't really cover everything of Numpy. What we'll do is, well, since we've got the last 20 minutes today, we will also quickly brush up on this library called as Pandas. So as with NumPys, we had created arrays. With the help of Pandas, we again have two data structures. We have a single dimensional data structure and we also have a multi-dimensional data structure. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as a data frame. So the series object is just a one-dimensional labeled array. Now, when I say one-dimensional labeled array, one dimension again means it's just that this is presented just one single column, and the labels are basically the index values over here. And as we had imported the NumPy library to work with NumPy arrays, to work with series and data frame, we'll have to import the Pandas library. So we start off by giving import pandas as pd, and once we import the library, we will use the series method. So as you see over here, pd.series, again inside this I am just passing in a list of values and I am storing it in this object called as s1. And when I print this out, this is what I get when I check the type of it. And you would see that this is a series data frame. So let's again head to Jupyter Notebook. So I'll just add a quick comment over here. So if you have attended my previous sessions, you would know that comments are something which are not executed by the Python interpreter. So we will start off by loading the Pandas library. I'll write down import Pandas as PD. Once we import this library, we'll have to create a series object, and to create a series object, I'll write down pd dot series, and inside this I will just pass in a list of values. So I will have 1, 2, 3, 4, and 5, and I will go ahead and store it in this object called as S1. Now when I print out S1 over here, you would see that I have created a series object where I have the values 1 to 5, and these are the indices, or these are the labels. Just to be sure, if I check the type, so inside the type method, you would see that this is a series pandas.co.series.series data frame, and this is what we are getting over here. So once we create this series object, we would so as you see, we have all of these index values over here, and if we want, we can also go ahead and change the index values. And to change the index values, I will use this attribute called as index, and inside this I will just pass in the new indices over here. So as you see, initially the index values were 0, 1, 2, 3, and 4. And here we have A, B, C, D, and E. So we are setting in the new index values. And here you see this is how our series object initially look like. And this is how our series object looks after the after changing the index values. So I have copied the same thing and I have pasted over here. I'll use this attribute called as index. So here I have 1, 2, 3, 4, 5. So for this I'll have A, B, C, D, and here I'll write down E. So this is present right in front of you. Initially, this series object, these were the labels. Here we have made the modifications, and these are the new labels now. So this is a single dimensional data structure at Pandas. Now we will quickly head on to the data frame actually, because we've got only like a couple of minutes of time. So let me also quickly cover this. So so as series was a single dimensional data structure, we've got a data frame which is a two-dimensional data structure. So you can compare this data frame to, let's say, if you have work with SQL, or if you have work with maybe Excel, you would know that you have something in a tabular format. So whatever is present in the form of rows and columns, that is that is what you can call as a table. And when you load this table in Python, this is normally treated as a data frame. So you can consider data frame to be the tool with which you can work with tables. To folks who had the previous sessions, you would know what is a dictionary. So now we are creating a data frame from this dictionary over here. So we have this dictionary where we have these two keys, name and marks, and we have the corresponding values. So the values for name are Bob, Sam, and Danny, and the values for marks are 76, 25, and 92. Now, to create the data frame, I'm using this method called as pd.dataframe, and inside this, we are just passing in this dictionary, and this is the result which we get. So here, as you see, the keys become the column names and the values become the records. So this is how you can create a dictionary out of, you can create a data frame out of a dictionary. So here I will write down pd dot data frame. Again, here you would have to keep in mind that this D has to be capital and F also has to be capital because Python is case sensitive. So inside this, I will create a dictionary. So first, I will maybe given the I have to give it the first key, which would be, let's say, student. Inside this, I'll give it names. So let's say first student is Annie. Then we have, let's say, Julia. After that, let's say we have Susie. So these are the three students which we have. But then I would want to write down the marks. So I would create another key called as marks. And then I'll give in the list of values. So let's say Annie has scored 67 marks. Julia has scored 98 marks and Susie has scored only 34 marks. This I will store in this object called as df. Now if I print this out, you would see that I have successfully created a data frame or a table which has rows and columns. Again, we will check the type of it. So inside type, I will pass in df. You would see that this is a data frame. So guys, we are actually, so there's a lot to cover in both Numpy and Pandas. This is a live session, and this is majorly aimed at giving you guys an intro to these libraries. This is what we could cover today. And also, since not in the best of my health, I might have not been able to explain it properly. So anyway, this Sunday most probably will have a Q&A session where we'll try to, if you want to know anything more about Pandas or Numpy or whatever we have covered in the last 5 sessions, you can put up all of those questions. We will take them up. So maybe in today's and tomorrow's time, you can watch the last 3 videos and you can just list down all of the questions with respect to those 3 videos, and whatever questions you have, you can just put them out. You can put them out, all of those questions, in the next Q&A session. Right. So guys, thank you very much for attending this session. So I'd like to take a leave now. And also, before you guys sign off, if you could just quickly, again, if you haven't yet liked the video, if you could guys just hit the like button. And also, if you haven't yet subscribed to our channel, if you could also subscribe, that would be wonderful. So thank you very much. Let's meet in the next session, guys.